interesting guy. He was also probably the biggest egocentric person in the world, and he gave that to every doctor that came after him. What did he find? He found aerobes and he found anaerobes. He connected oxygen with the growth of organisms. And he also invented the term germ. That's a rather inclusive of everything term. Yeah? What?
Is that Pasteur?
Yeah, that's Pasteur, right. I didn't leave him yet. Yeah, he invented the term germ, and he came up with the germ theory of disease. It was not specific, but he did say that disease actually came from a germ instead of from God. And so that really was progress. In the mid-1850s, a lot of stuff was going on. In England, they had done a study, a public health study, to see what the average age of death was. And they compared people who lived in the country to people who lived in the city. The average age of death, if you lived in the city, was 18. If you lived in the country, it could go as high as 25. If you were a laborer in that category, you were dead really early. So that allows us to understand how Romeo and Juliet came to be at age 13, because if they were going to be dead at 21, they didn't have a lot of time. An interesting theory about that. So if you were a laborer and you worked in a city, you could live to be 21. If you were a laborer in the country, you got a few more years to go. If you were a landed gentry man, in other words, you had servants, you didn't do the basic stuff, you could possibly live to the age of 40 in a city and to the age of 57 in the country. So the lifespan wasn't really big. And what's funny about that is nobody ever hit the age of menopause, so it wasn't a problem. You never read about any menopause when you read about some of the poems and stuff like that. Over here, in 1900, the average age of death was 41 if you included women, and 47 if you did not include women, if you took them out of the mix. So in 100 years, we've doubled the lifespan in this country. What about the next 100 years? Will we double it again? Is 200 a reasonable expectation if you are born in, let's say, the next decade? Would that be an expectation? So you could go to 2,500, you're born in 2,300, you go to 25. That's amazing. How are we going to feed everybody? Yeah.
My anatomy and physiology lab instructor last year said that they had, everybody's heard of the biodome?
Yeah.
They basically enclosed people into this experimental facility for a year or 2 years. They only eat what's in there, they only get their whole world is in this closed environment. And they said they examined them when they took them out and looked at the way their bodies had degraded or not degraded. And they said that if they lived in there, in that kind of a structure, with that stress rate, with that kind of food, with that kind of purity of the water and whatnot, that they would survive till about 180.
Wow. Human cells taken out of the body have a laboratory lifespan of what would equal 200 years. Put them back in the body with every other organ impacting their outcome, and you change the lifespan by reducing it 1/2. But if you take cells out of the body, you can make them equal 200 years for the generations of reproduction that would happen. And that's because there's a microenvironment that takes care of us, as well as a macroenvironment which we're living in. So we all have to go find a biodome, is that the deal?
I'm looking.
You're looking, he's looking. How many people were in it? I don't remember. I read about it.
Half a dozen or something like that.
Yeah,
It was
it's a very small
very
group,
controlled
right.
experiment.
Well, they have some other TV program about the dome, you know, there's some other bunch of people living in a dome. I didn't watch that either. So, anyway, keep your eyes open. Tell us what stuff is going on. So here's Pasteur, and the people in England studying public health. Public health became the issue when people aggregated in cities. And if you remember some of the history, around Western Europe, every now and then a whole city would burn up. Because the structures were wooden and they couldn't really save them. And there was the historic London fire, they had fires all over the place. And it might have been sort of like a population control. Because if we can all go to 300, how are you gonna feed everybody? Where are you gonna feed them? Are there gonna be colonies on Mars because we don't have enough room here? God bless you. That's an allergy, right?
Mhm.
Good. If it's a cold, we all have to, right. So these are the things that were going on and that people were concerned about. I give Pasteur a lot of credit. I don't give him all the credit in the world that he would like, but the Pasteur Institute in France is a very wonderful scientific community, so I have to acknowledge that. Okay, so that's like 1850, we're about 50 years to go to the 1900s. What's gonna happen along the way? A man by the name of Tyndall comes along right after Pasteur, and he tried to work out how you could produce a living organism-free material. How could he get rid of the organisms? He knew all about the work that showed that there were the opportunities to boil things and you could kill the organisms. He also read up on how you could break them open and they still had live things in them because they weren't boiled long enough. So what he decided to do, and his name was Tyndall, was to try a different experiment because boiling really is a very aggressive form of activity. It changes proteins, it denatures proteins. So Tyndall tried an experiment where he raised the temperature just up to the 63 degrees, and then he lowered it. And the spores would form down here and become vegetative. Then he would raise the temperature again and lower it. And up here, he killed all the vegetative forms, and down here, all the spore forms survived. So he carried this out long enough, so in the end, he had only vegetative forms. He had no spores. He got rid of the spores. And that's called intermittent sterilization. Intermittent sterilization. Because it doesn't bring everything to a high enough, I can't write and talk. Doesn't bring everything to the highest possible temperature. So Tyndall gets credit for that. And he's again in the mid-1800s working on this stuff. And then along comes a guy who is very interesting to us, Joseph Lister. And you know about him. He worked on surgery in the hospitals. He worked on the control of sepsis. Sepsis is an infection, and it is usually by bacteria. Does it include viruses? No, it doesn't. So it's very, very much limited to bacteria. But if you allow microorganisms to run rampant through the blood, you will get sepsis. And so his work was, how do you block that? How do you block that? Therefore, his work was in anti-sepsis. So what he found is the use of certain agents could kill microorganisms. And what was the agent that he used? Carbolic acid. Carbolic acid has the power to kill just about everything. So he recommended to these people developing in the medical community that they soak their instruments in carbolic acid before surgery. And he would run around the operating room spraying carbolic acid all over the place. He and another guy named Semmelweis, and you may have heard of Semmelweis, and they both came to a very bad end, by the way. Semmelweis was working around pregnant women who were giving birth. And what he suggested to the very, very exotic surgeons is that they wash their hands because they were coming directly from the morgue where they were carving up dead bodies loaded with bacteria to deliver babies. If you went to a hospital in the mid-1800s to deliver a baby, you really had very little opportunity to survive because they really didn't know what they were doing. If you had a baby at home with a midwife or your relatives who had experience with this, they used a lot of hot water, they used a lot of clean cloths, and you had a much better chance of surviving. Otherwise, you would probably die of childbed fever, and that was very, very common. So even in the early part of this country, when people didn't know how to preserve life, it sometimes took 2 or 3 women to raise a family. We are at a time when we can sit around with an enormous amount of confidence that if we want to procreate, we might be able to have the offspring that we want that is free from disease or any of the things that could be passed on, because we have all kinds of prenatal testing. We have in vitro fertilization. So the idea that you can make a designer baby and it's going to live to be 200 is real now. Back then, it wasn't. People didn't know enough to be able to have families that survive. So all this stuff is swirling around and it's really amazing. Lister tried to produce antiseptic surgery. Antiseptic surgery. And Semmelweis tried to produce a safe environment for women to give birth. And that's what he recommended. And I say this because if you've ever worked with medical personnel, do you think they would have been willing to listen to these two people? I don't think so either. I think that their attitude would be, I know what's best, get out of here. So they were both abused, they both died as drunks and poverty-stricken, and yet their contribution to the world was huge and enormous. Yes, Robert?
I thought Semmelweis died in a psychiatric hospital from childbed fever.
Yeah, they went nuts,
Yeah.
but they became alcoholics, they lost their all the money that they had, they were penniless. And yet they made these big contributions, which now, 150, 200 years later, we say, oh, isn't that nice for us? So to be out there on the cutting edge, is really something.
They use his name.
All right, so while this is going on, we're getting now to the latter half of the 1800s. In 1860, here comes Robert Koch. And he's really interesting because he's developing a lot in the field of microbiology. And what he works very much on is media. How do you make media that can grow organisms?